Hi, today we will be discussing Lab 2 of Physics 2212, Lines of Charge. In this experiment, we will conduct the same experiment as Lab 1, but use a more sophisticated model for calculating the electric force on the piece of charged tape. The diagram shows the general setup of the experiment, where tape B is suspended while tape A is brought closer and closer until tape B floats over its original position. Later, we will see that the charge from the line charge model is smaller than the charge from the point charge model used in Lab 1. First, we will look at the fundamental physics principles behind this lab. Charged objects produce electric fields that point towards negative charges and away from positive charges. The electric field of one charge interacting with a different charge produces an electric force. The electric field of a line charge is modeled as a line of multiple point charges. Each differential charge produces its own electric field, and these differential electric fields are summed up using integration. A summary of this process is shown on the image on the right. It is also important to remember that gravity exerts a force on all objects. The electric force from tape A is counteracting the force of gravity on tape B, causing tape B to float. Here are the data and results from the experiment. Each piece of tape had a length of 0.21 meters, and the mass of each tape was 2.1 times 10 to the negative 4th kilograms. The distance to achieve floating was 0.022 meters. The magnitude of the gravitational force on tape B is its mass multiplied by acceleration due to gravity, which results in 2.06 times 10 to the negative 3rd newtons. This is also equal to the magnitude of the electric force on tape B, since the forces are balanced. To simulate the forces experienced by tape B, this model was coded using GlowScript. The model is shown on the left and the calculation results are shown on the right. This model approximates the pieces of tape as line charges. The red line of charge is tape B and the blue line of charge is tape A. The white arrow represents the electric force, which has a magnitude of 2.0601 times 10 to the negative 3rd newtons. The yellow arrow represents the gravitational force, which has the same magnitude. The arrows are centered at the middle of the red line of charge, which is why the yellow arrow seems shorter, but in fact they have the same magnitude. The green arrows represent the differential electric fields at each of the point charges on tape B. The charge on each piece of tape is 7.76031 times 10 to the negative 9th coulombs, which was found by trying different values until the electrical and gravitational forces were equal. Now we will look at the actual code behind the model. The first function shown calculates the electric field after taking in particle and observation location parameters. The second function then creates lines of charge using the input parameters. The top tape and bottom tape objects are the actual lines of charge that are output as seen on the previous slide. The nested loops are used to calculate the electric field and force on the top tape from the bottom tape. Each differential electric field is displayed as a green arrow. Then, each of the differential electric fields are used to calculate the corresponding differential electric force. The differential electric fields are added together to get the net electric field, which is then used to get the electric force on the top tape, which is shown as the white arrow, and the gravitational force is also calculated and shown as the yellow arrow. The arrows are scaled accordingly to make sure that everything can be seen properly. There were a few assumptions made in this lab. First, we ignored air resistance. We also assumed that each piece of tape had an equal amount of charge evenly distributed along the length of the tape. This is different compared to Lab 1 when we assumed each tape had all of its charge concentrated at its center, as if it was a point charge. The charge from the line charge model was 7.76031 times 10 to the negative 9th coulombs, which is smaller than the charge from Lab 1's point charge model, which was 1.05202 times 10 to the negative 8th coulombs. This occurs because each model calculates the charge differently based on the geometry of the situation. The line charge model is probably more accurate since it is a more realistic representation of the actual experiment. Thank you.